Byte of Truth. Quantum leaps and market jitters. Europe's AI crossroads.
Is the AI hype bubble finally bursting or just growing up? Welcome to Byte of Truth. I'm your host, Sébastien. And this week, we're standing at a fascinating crossroads. On one side, Wall Street is getting a case of the jitters. With AI stocks looking a little shaky, investors are starting to ask a very simple, very important question. Where's the profit? But on the other side, we're seeing moves that signal a long-term bet of almost unimaginable scale. OpenAI is asking the US government for billions in infrastructure support. And in the labs, scientists are making discoveries that could fundamentally reshape the very foundation of computation. It's a week of contradiction, of market jitters and quantum leaps, of investors pulling back while the push for more power accelerates. Today on Byte of Truth, we're untangling this mess. We'll start with those wobbly markets and why OpenAI needs a new kind of CHIPS Act. Then, we'll dive into two stunning breakthroughs in quantum tech that might just be hiding in plain sight. We'll explore how AI and satellites uncovered a secret carbon bomb in Antarctica. And finally, we'll ask why Hollywood is suddenly so eager to declare, yep, a human did this. Let's get into it.
AI market realities.
Let's talk about money. Because for all the talk of artificial general intelligence and changing the world, the story of the week is that Wall Street seems to be losing faith, not necessarily in AI's long-term promise, but in its short-term ability to make a buck. A recent analysis showed increased volatility in tech stocks, with the pure-play AI companies taking some of the biggest hits. The story isn't that these companies are failing. It's that the gap between their sky-high valuations and their actual tangible revenue is becoming, well, a little uncomfortable for investors. Think of it like this. We've all been sold a ticket for a trip to Mars. It sounds incredible. But now, people are looking around and asking, okay, but where's the spaceship? And who's paying for the fuel? Investors are starting to demand more than a promise. They want a profitability roadmap. And right now, for many AI companies, that map is still very much a work in progress, especially when you compare the cautious sentiment in some European markets to the growth at all costs mentality that's dominated US tech. But here's the twist. The very same day you might read about investors getting nervous, you can also read about OpenAI, arguably the face of the current AI boom, making a very big, very expensive ask. They've gone to the Trump administration with a request: expand the CHIPS and Science Act. That's the massive multi-billion-dollar US initiative aimed at boosting semiconductor manufacturing on American soil. OpenAI isn't asking for more chips for themselves. Not exactly. They're asking for a key part of that act, the Advanced Manufacturing Tax Credit, to be expanded to cover something new: data centers. Right now, the credit is for building fabs, the factories that make the chips. OpenAI is saying, hey, the buildings that run the chips are just as critical to national security and technological leadership. You should help us pay for those, too.
Infrastructure and policy.
So what does this mean? It means OpenAI is acknowledging a fundamental truth. AI isn't just software anymore. It is a heavy industry. It requires immense physical infrastructure. We're not talking about a server closet in the office. We're talking about facilities that consume as much electricity as a small city, packed with the most advanced hardware on the planet. And OpenAI is essentially telling the US government, if you want to lead in AI, you can't just focus on making the chips. You have to help us build the warehouses to put them in. This has huge geopolitical implications. It highlights a growing infrastructure gap, especially in places like Europe, which is facing a significant data center shortage. If all the most powerful AI models have to be trained in a handful of massive, subsidized data centers in the US, what does that mean for the rest of the world's digital sovereignty? It creates a new kind of resource control, not for oil, but for computation. Europe is watching this very closely, I assure you. It's a high-stakes game, and the lobbying has only just begun.
Quantum revolution.
Okay, let's shift from the world of finance and policy to the world of pure, unadulterated science. Because while the market debates dollars, some researchers are busy rethinking the very atoms of computation, and their discoveries are, to put it mildly. First, from MIT, a team working with something called magic angle graphene has made a step toward a dream that has eluded physicists for decades: a room temperature superconductor. Now, what is magic angle graphene? Imagine a sheet of carbon atoms, just one atom thick. Now, place another sheet on top of it and twist it just a tiny bit, precisely 1.1 degrees. At that magic angle, the electrons start behaving in bizarre, cooperative, almost magical ways. The MIT team found that under these specific conditions, they could get graphene to exhibit properties essential for superconductivity at temperatures far, far higher than before. Why is this a big deal? Superconductors are materials that can conduct electricity with zero resistance. Think of it like a frictionless wire. The problem is, most of them need to be cooled to near absolute zero, which is expensive and complicated. A room temperature superconductor would change everything: power grids, medical imaging, and yes, quantum computing. And speaking of quantum, let's go from MIT to Stanford. Because while the graphene story is about creating new materials, the Stanford story is about finding quantum promise in something incredibly ordinary. They've discovered that a crystal called strontium titanate has some extraordinary properties when you cool it down to cryogenic temperatures. This isn't some rare exotic element. It's a crystal so common you can find it in undergraduate physics labs around the world. The Stanford team found it could host a unique, quasi-particle that is incredibly resilient. It doesn't get knocked off course by outside interference, which is one of the biggest problems in building a stable quantum computer. A cheap common crystal that could hold the key to protecting quantum information, that's like finding out the secret to a clean energy engine was hiding in a garden rock all along. Together, these discoveries from MIT and Stanford suggest that the path to a practical quantum computer machines that could solve problems in minutes that would take today's supercomputers thousands of years might not be a single straight line. It might be a mosaic of different surprising materials, each solving a different piece of the puzzle.
AI in climate science.
Let's bring things back down to Earth. Or, more specifically, down to Antarctica. For a long time, monitoring carbon emissions in the Antarctic during winter has been a huge challenge. It's dark for 24 hours a day. It's the polar night. It's incredibly remote and brutally cold. Traditional satellites that rely on sunlight simply can't see what's happening. Enter a new system of laser satellites combined with a hefty dose of artificial intelligence. These new satellites use LiDAR, essentially laser pulses, to map the surface and the atmosphere even in total darkness. But the data they collect is massive and incredibly complex. That's where the AI comes in. An AI model was trained to analyze these laser readings, distinguish between surface ice and atmospheric gases, and quantify carbon release. And what it found was a shock. The AI analysis revealed that the amount of CO2 being released from the Antarctic landmass during winter was being severely underestimated. How much? By about 40%. A 40% undercount is not a small error. It's a gaping hole in our climate models. This kind of finding forces a complete re-evaluation of how we calculate the global carbon budget. It means Antarctica isn't just a frozen reservoir, quietly locking away carbon. It is an active, and previously misunderstood, source of it. This is a perfect example of AI's immediate, tangible impact. It's not some abstract future promise. It's here right now, taking a new kind of data from a new kind of satellite and turning it into critical knowledge for our planet's future. And for a European audience, this has special resonance, as the continent's own Copernicus Earth observation program is a global leader in this space. This discovery just adds more fuel to the argument that we need to invest more heavily in these kinds of AI-powered climate monitoring systems.
Human vs. machine creativity.
Finally, let's end in the world of storytelling. Vince Gilligan, the creator of the legendary show Breaking Bad, has a new series on Apple TV+, called Pluribus. It's a political thriller, but the most interesting part of its recent press tour wasn't the plot. It was the disclaimer. The marketing for the show has been emphatic, almost forceful, in declaring it was made by humans, not generated by AI, not co-written by an algorithm, made by humans. It's a fascinating cultural moment. On the one hand, you have companies like OpenAI building massive godlike data centers. On the other, you have creators anxiously insisting on their own humanity. Why? Because in a world flooded with AI-generated images, text, and music, human creation is becoming a premium product. The human-made label is becoming a new kind of marker of quality, of authenticity, of soul. It's a direct response to the anxieties around AI's role in creative industries. And it's not just a marketing ploy. It's a statement about value. This is where policy and culture collide. The EU's AI Act, for instance, will soon require transparency for AI-generated content. You'll have to label what the machine made. This Pluribus campaign is a preemptive strike. Its creators saying, "We're not just complying with a label. We're proud of the label we're already using." This debate, this tension between what we can automate and what we choose to cherish as a uniquely human endeavor, is going to be one of the defining stories of our time. It's not just about who gets the writing credit, it's about what we value. So, a strange week, isn't it? A week where the markets question AI's present, while its architects lay the groundwork for a future so powerful it requires government-level investment. A week where scientists find quantum potential in a common crystal, and AI uncovers a giant secret hiding at the bottom of the world. The stories we covered today aren't separate. They are all connected. They are all signs of the profound transition we are in. A move from AI as a clever software trick to AI as a foundational piece of our global infrastructure, our scientific understanding, and even our cultural identity. The hype isn't bursting. It's just getting real. And that brings its own set of questions. Not if AI will change things, but how. And who gets to decide? And what are we willing to pay with our money, our resources, and our sense of self to make it happen? That's all for this edition of Byte of Truth. If you found this interesting, share it with a clever friend. Thanks for listening. The true measure of our AI-driven future will not be found in market caps, but in the quantum leaps we choose to take for our planet and our humanity.